How's it going? Welcome back to the channel. In today's video, we are building a 13.5:1 compression 416 cubic inch short block for our buddy Jake Wise and his drift car. Jake brought down his LS3 combination to us that he ran last season and basically needed the smedding treatment. So we're going to increase the displacement, we're going to put a little bit more compression in it, and as well get him a custom camshaft to match the new combo. Jake is with us today. He was able to come down, and so we are actually going to build the engine together. Actually, surprise for Jake, he's going to build his own engine, and I'm just going to walk him through the process.
Man, I didn't see that coming. Let's do it.
Cool. Have you ever built motors before, Jake?
No, never.
Never done something with your uncle or grandpa? Small block 350 in the shed?
My family was not the type to do that kind of thing. My parents took cars to the dealership for oil changes. So
Gotcha.
Everything I know I taught myself, and I've never done anything like this.
Well, cool. You'll be surprised that as we start going through this process, engines are amazingly simple, and as long as we follow the recipe, they go together as they should. Now, luckily to save us a little bit of time and the hard work, Shay has already prepped this entire process for us. So the main bearing clearance is set, the rod bearing clearance is set, and the ring gap is all set. Speaking of rings and pistons, to get us to 13.5:1 compression, we're going to run these Mahle forged 2618 pistons with a 9cc dome. These pistons are super nice. They have a 1mm top ring, 1mm second ring, and 2mm oil ring. The top ring is stainless steel, the second ring has a Napier hook for oil retention, and the oil ring is low tension. Jake is going to run a little bit of nitrous in this combination, so the ring gap is also set for that. We're running 26 on the top and 28 on the second. So, with all that said, let's get to stuff in this motor. Okay, Jake, step one to your engine. We're going to install the camshaft first. And we're actually going to install it dry with no lube on it, because once we get it properly inserted into the block, we can kind of give it a little bit of a wiggle test back and forth and make sure that all the bearings are perfectly straight and aligned. So we'll get her popped in there. Sometimes, yeah, you can take your other hand on the back and just kind of gently glide her in. Come around the back of the block here. And just like that. All right, camshaft is in. Now let's do a quick little wiggle test to make sure that all the bearings are properly straight. And what we're kind of looking for is that there's no weird spots inside the motor. And so now that our camshaft is in, we can just slightly push it to the front, just a hair. I usually go right about, oops, too far. Right there, that's perfect.
Cool.
And now we'll grab some lube. Remember, boys, to always lube your shafts. And we'll get her nice and coated. That way when he fires this thing up, all the bearings are protected. Alright, now what you're going to do is, while you're pushing it back into place, kind of rotate it if you can to get those bearings coated. It might be a little difficult without a gear on there, but yeah, just like that. He's a professional. He's obviously done this before. What am I doing? Alright, next we're going to install our thrust plate. So let's get these bolts out.
Okay, so we lubed the shaft, and now we have to thrust.
There you go.
Gotcha.
He's a natural, people. Alright, now's the fun part. Let's go ahead and grab your crankshaft. So this is one of our Smedding Performance 4340 forged 4-inch stroke crankshafts. Go ahead and set it down right here. That'll be just fine. And so it has already been balanced to his bob weight. Reluctor wheels already popped on. And again, we've already checked main bearing clearance. Because this is a drift car that's going to live at RPM for extended periods of time, we're going to run a little bit more main bearing clearance than a normal street car application. And so this engine, currently cold, has about 2.3 to 2.5 thousandths of clearance. And because it's an aluminum block, that will grow about a half a thou. So let's grab this jug of lubricant.
Okay.
And everything's already nice and clean. Cleanliness is the biggest part of engine building. And go ahead and lubricate your main bearings, as well as let some kind of droop down onto that camshaft down there.
How much should we be doing here?
A little goes a long way.
Okay.
So don't need to be super generous, but we want to be a little.
About like that?
That's perfect.
Cool.
And we'll come back and lubricate it again on the other side once you drop the crankshaft in there. One of the other big reasons I like to install the cam first is now we can immediately get lubricant all over, I don't want to say it, but Jake's shaft here. Alright, man. Grab your crank. I usually hold it on the front wheel, or the front snout, and then on the back, you can kind of see there's these 4 ring holes, kind of looper there. And I'm going to come to this side of the motor, and I kind of pick her up, hold her over, and center up this bearing with the block, and just kind of use that as your reference guide, and it will fall itself right into place.
Like a glove.
Yep.
Look at
Perfect.
that.
There you go. Pretty simple, huh?
Yeah, it's really not that bad at all. It makes it seem like it's real complicated, but it's not bad.
It's about to be.
So far, anyways. Yeah, we'll get there, I'm sure.
Cool. So now, like I said, we'll come back with a little bit of lubricant and just drizzle a little bit again on the top of all the journals. The engine assembly process is very, very straightforward. The kind of technical experience part comes with the ring gap, the bearing clearance, the balancing, the machining. Don't forget this last one.
Yeah, those are the parts of your videos that always got me thinking you're some mad scientist or something.
See, I got him fooled, boys. Shay, we're doing something right. All right, cool. So the crank's in. Now we're going to start with the center bearing, your thrust bearing.
Okay.
And the thrust bearing, you can see, has these flats on both the back and the front.
Yep.
And that basically retains the crankshaft's thrust, the fore and aft play, as it rides inside of the block. So we're going to install it first, and you'll see that they have a little bit of an arrow on them.
Gotcha. That goes towards the front of the motor?
The front of the motor.
You go like this.
You got it. So drop him in first, and it won't seat all the way, and that's fine.
Okay.
And now let's grab that blue hammer, and using the base of the hammer, just kind of lightly tap it down and seat it into the block. Give it a good whack. Perfect.
Cool.
All right. Now we're going to set our thrust bearing clearance and check it to make sure it's what it's supposed to be. So let's grab a couple of these. We'll pop these on here like so. And basically what we're going to do is we're going to lightly install that center main cap onto the block at about 10 foot-pounds of torque, very light. That way the cap is seated to the block, and then we can check the crankshaft's thrust play. Alright, this next part is going to look a little scary, but we're now going to seat the thrust bearing to line up the cap and the block. And I'm going to take a big hammer and slam the front and rear of this crankshaft. So don't be alarmed, this is definitely normal.
Guess that's the not so finesse part about this, huh?
Yep, again, if it doesn't fit, hit it with a hammer. Yeah, a lot of people really freak out at that stage, and they think you're going to hurt the crankshaft somehow. It's like, dude, that crank's going to turn damn near 8,000 RPM.
I say it's going to see a lot more energy than that in its lifetime.
So much more. And
how many times you clutch kick the car?
Yeah.
same thing.
Way harder than that.
Yeah.
So right now, if I push the crank all the way to the front of the engine, you can see we're zeroed. We've got our dial bore gauge zeroed out. And now I'm going to just with my hands, just pull the crankshaft to the rear of the engine, and we've got exactly 5 thou thrust, which is perfect. So that's good. We don't have to take the bearing out. We are ready to keep going. Okay, Jake, now we're just going to grab the other main caps, drop them on the motor, and then we can start threading on all of these nuts onto your studs.
They don't go in any particular order?
They do.
So
Yes.
this one says 1 on it. So
Yep.
it goes in front.
Pretty intuitive.
I'm going to make that pretty easy for you. How much nitrous can this thing run, do you think?
250.
250?
250 would be about the max.
I don't know if I would ever do that much.
Yeah,
but
probably.
I was
wouldn't
thinking.
go that high unless you really. With drifting, do you ever like get in a situation where you need like 100 more horsepower?
Yeah, so the big misconception with drift cars is that they're set up to be loose. Like setup wise, they're probably some of the most hooked up cars there is. Like they're real fast drift cars are extremely hard to drive. They want to kill you the whole time you drive them. So, I mean, like a lot of the pro guys nowadays run like 315, 40, like semi-slicks basically. So if you're driving on a track that's like high speed, those guys, it's like RTR, the Ford FD team, they run like 800 NA, and then they make about 1200 on spray. If the nitrous goes out, they can't link the track. Like that's how hooked up they are. So a lot of the events I'm going to be running this year are a little bit bigger tracks with a lot of fast drivers. I'm going to have the car pretty tight. So yeah, in those cases, I might need more.
Cool. I did not know that.
Yeah, that's the biggest misconception. Most people think they're just set up to be as loose as they can. Not at all.
Opposite.
Yeah, the exact opposite.
Interesting.
In most cases, anyways, if you want to go fast. Yeah, the motor set up bad last year. It did pretty well, but if I put a real tire on it, it would struggle. Yeah.
All right. Go ahead and grab that impact and socket, and then just start in the middle. And just go boom, boom, outside, outside, inside, inside, outside, outside, inside, inside, outside, outside.
Just side to side?
You can just go to 1, 2, 3, 4, 5.
Okay.
And you can run it down. Just let it. You can let it. It's turned down so low. Yeah. So.
Just like that.
Yep. So in that case, go ahead and crack it loose.
Okay.
And then just hit it again.
So what is the difference when it does that? If that makes sense.
It can just sometimes, if you get it close, so like the breakaway torque to get the nut moving again can sometimes be 10% more than what it actually is. So if you're trying to hit 60 pounds and you get it to 55 and have to reset, the wrench might click 60, but that was just to get the nut breaking and get it back into motion.
That does make sense.
So that's why you want to hit it on just a clean linear pull.
Yeah.
Instead of kind of ratcheting it all the way up.
It's the kind of stuff that you don't know until somebody tells you that.
So that one I'd probably stop right there, reset. No, you don't have to reset there. Just come around. Just reset the wrench and then.
Gotcha.
There you go. Sweet.
Cool.
Now let's click it down to 50 pounds.
Okay.
You can just lower arrow. And then you're going to do the exact same thing on the outer studs.
All right, there's all those.
Cool. Simple as that. Crankshaft is in.
That's all they get torqued to?
Yep. Surprisingly light.
Man, I would think that'd be way heavier.
Yeah, only 50 and 60. But because, I mean, there's 4 in each cap, the clamping force is insane.
Yeah, that's fair.
But cool. Next step is we're going to put the side bolts in.
Okay.
And then we can continue the front of the motor, dress off the timing chain, the oil pump, and just keep plugging away.
All right.
Okay, next we're going to do the timing set. And if you look at the front of this gear here, you can see that there's a whole bunch of little numbers going all the way around it. Those are basically if we wanted to advance or retard your camshaft.
Okay.
And that's kind of like a band-aid, if you will. So like if a camshaft is too small for a combination, you can retard it a little bit and it will make a little more top-end power, and vice versa. If it's too big for a combo, you can advance the camshaft, make it open the intake valve sooner, and it'll shift the torque curve a little bit down. Your camshaft's custom cut to the combo, so it doesn't need that. So we're going to run it straight up on 0. And so anyways, you can see that on this part of the gear, on this key, there's a 0 marker that's splined onto the crank.
Okay.
And then on the teeth itself, we've got another 0 marker. If you look farther around, you can see a -2, a -4, and we would line up on those if we had them keyed plus or minus, advanced or retarded.
Okay.
But on the chain, you only have the 1 dimple. And so all you have to do, or not the chain, but the gear itself. And so basically, we're going to pop this up there, and you're going to get it lined up. Your bolts are over there.
Okay.
And then kind of bolt it up, and you're just trying to make sure that this dot matches that 0 tooth count
That one right there.
on the crank gear.
Cool.
And so that actually, real quick, if we can show the viewers, that timing set, flip it around, is really cool. It's got a bearing on the back side of it. So at real high RPM, when everything's moving around, the camshaft is supported and the gear is supported by that bearing riding on the thrust plate.
And that's not normal?
Nope, normally they don't have that. Normally it's just metal on metal
Oh.
with a little bit of thrust clearance. And so the gear is a little bit of a nice little upgrade.
Nice.
So I would try to get it on the chain, to get the chains lined up first, and then the camshaft will fall into place. So it looks like we're about a tooth off, so you can just reclock it. One tooth, perfect. Oh, maybe a little too far.
The finicky stuff has begun. Right
There it is. Yep, that's it. Now just grab your bolts, that little socket up there to help install, thread them in, and it'll pull the camshaft up to the gear and kind of help line everything up again for you.
And not that many moving parts to these engines, huh?
No, the pushrod motor is very, very simple. A lot of the magic that makes LS's good is the cylinder head and then just the overall structural rigidity of the block. But as far as the rest of the motor, they're extremely simple.
So would you say for like my application, would you recommend an aluminum block still for that? Or do you think there's any advantage to going with an iron block?
So for what you're doing, so yeah, I'm just checking real quick. Looks like we're perfectly lined up. Cool. So we can go ahead and torque these bolts down and keep moving on. I'll get to that question in just a second.
Because that's a pretty hot debate in the drifting world. So a lot of people run the iron blocks and they think they're superior.
So at your horsepower level, naturally aspirated, this thing's probably going to make 705 or 710, right around 700. Plus nitrous, so you're still right around probably 950 to 1,000 if you turn this thing all the way up. That's about the limit of this aluminum block. I've seen guys making 1,200 on turbo stuff before.
Okay.
So they can go further, but I wouldn't rate it safely above 1,000.
Gotcha.
So for what you're doing, I would say aluminum block. Oops, I'm sorry, I'm not strong enough. Let me get a better grip. Go for it.
Good.
Yep. Cool.
And the weight distribution matters so much. At least definitely in drifting, because we want the weight to be pretty centered, but we want it to be proportionally on the rear wheel to an extent, because that helps us with traction in drift. Because that's like one of the big misconceptions like we were talking about earlier,
right,
is that you want drift cars to be as grippy as they can. You want to be really hooked up and hard to drive so they can be fast. So I always don't like to add any weight over the front if I can help it. But there's always a big debate going on if iron blocks or aluminum blocks are superior. So that's kind of interesting to know that 1,200 is probably about the top.
Yeah, yeah, that block, you'll be able to make 1,000 on this for a while without any issues.
Okay.
And even at that point, yeah, I mean, the iron is going to be stronger, but what a lot of people don't realize as well about the LS3 block is its cylinder sleeve is actually longer than a 6.0 iron truck block. So if you're running a stroker crankshaft, because the sleeve is longer, when the piston comes all the way down to bottom dead center, it still has more support all the way around it.
Did not know that. I thought they were all the same.
Yep. And then if you step up to like a dart block like this, and this is an aftermarket block, of course, it's even further. So in these motors, we can run a 4.125 stroke crankshaft and have more support than this engine does with a 4-inch stroke crankshaft.
Is that about the maximum stroke that you can get out of like an LS3 block?
It's the most that we would run or recommend. There are guys who run the 4.125 stroke crank in LS3 blocks. I personally don't like that too much because the piston is so unsupported that I don't think they RPM very well or last that long. It may work for a drag race combo, but something that's going to be living at RPM for multiple sessions a weekend, for hopefully a couple seasons before a refresh, I'd stick right here.
Gotcha.
I think this is kind of where your money zone is going to be.
I think so too.
Cool. So that's all wrapped up on the front. Next, we're gonna pop our oil pump on. This is Melling's High Performance 10295 oil pump, they call it. And this is a standard volume pump, but it's a high pressure pump. So kind of in this little reservoir, we have what's called an oil pressure relief valve. And basically the oil pump will prevent the engine from making too much pressure and hurting something it's just got a relief valve. It'll open the relief and then it'll bleed pressure off back into the crankcase. Standard LS pumps are limited to 65 psi, but these can go up to 75, 80 psi. And so our general rule of thumb is for every 1,000 RPM of engine speed, we want at least 10 pounds of pressure for a push rod V8.
Yeah.
And so, so that we have what's called the Copo Camaro pressure spring, and that will give you the most pressure possible so that when using this thing to 74, 7600 RPM, it is solid and ready to go.
I see a lot of arguments online about people going high volume, high pressure, or standard volume, high pressure, and I don't really know which one's better.
Yep. So in our opinion, the LS, and it's not our opinion, it's factual, the LS is a very over-oiled engine to begin with. So one of the big things that the aftermarket does, like Dart for example, is they pull volume out of the oiling system actually to restrict the flow.
Really?
Because it's so over volume from the factory. So another thing too is this engine has a forged crankshaft, it's studded, and it has really nice forged H-beam rods. So when this thing's turning a lot of RPM and making a lot of power, it's not flexing those components basically at all. They're super rigid and super straight. So the actual housing bore that the bearing lives in isn't distorting and getting pulled and warped and moved around. So it's maintaining a tight tolerance. Because it's maintaining a tight tolerance, we don't need a ton of volume to make up that slack. Now, the inverse to that is if we were a stock block, stock bottom end Hero, and we had a stock crankshaft with some stock LS connecting rods trying to turn this thing what you're doing, then I guarantee you with those little rod bolts, this housing bore is going to be all over the place. That bearing clearance is going to be moving constantly. So in that situation, because we're gaining and moving bearing clearance, you could argue the high volume pump would be better.
Gotcha. That makes sense though. That's not an argument I've ever heard before, but that does make a lot of sense.
Yep. Yeah, so the stronger and the more rigid everything is, we have less distortion. And because of that, we don't need a crazy amount of volume going through the motor.
That's pretty logical.
So we've got this little gear, it's going to pop on, and then the oil pump will spline to it. Kind of finicky, just like that.
Finicky, huh?
Right, wow, making myself look good. And then I always Loctite the oil pump and the camshaft bolts.
Yeah, yeah.
They don't torque to a bunch, and they're not a loaded fastener. And what I kind of mean by that is like the main studs, the crankshaft is constantly pushing on them.
Yeah.
The connecting rods, the rod bolt is constantly being pulled back and forth. These bolts don't really do anything. They just sit there.
Yeah.
And because they're not loaded, I've seen stuff that's torqued properly to spec. They're a little bit loose when you take them apart. And so I always Loctite the hell out of these. The way we line up these oil pumps is I get it very lightly installed. So the bolts are as close to the block or as tight on the oil pump as they can be without actually retaining it. So the pump still has a nice little wiggle to it.
Makes sense.
I'm gonna take regular break-in oil and just fill her up a good bit. Put your balancer bolt in, and I just spin the motor over a few times. That gets all that oil lubricating all the gears. The gears moving in the housing kind of center up themselves in the housing, and then you can torque it right there, and it's good to go. Like
Those are the little tricks. I definitely would just put it on and torque it down, for sure.
And it would have worked fine, but you know, while we're here, any little thing we can do that might be a little bit better, even if it's just a theory. Let's exercise it. All right, man. Front of the motor is pretty much buttoned up. Now we have the fun part. rods and pistons going in the block. Fast forwarding just a little bit, the block is super clean. I just wiped out all the cylinder bores, and we've come back and lubricated everything with break-in oil. Again, everything over here is complete, assembled, ready to go with these super nice dome pistons and this really cool anodizing they do. It just looks badass. Yeah. So we're gonna do kind of the same thing. The bearings are already super clean, clearance is already checked. We're gonna take that big can of assembly lube and come back and just do a little bit of a drizzle on all the rod bearings themselves. And then we can install our first one into the block, and the next steps we'll kind of just follow and go from there. So these have super thin piston rings, so you need to be really careful that they don't get crossed or out of alignment. And that will gently and smoothly fit into there just like that. And I kind of bring it all the way down to the bottom. And then you want to do this in a very swift affirmative motion, if that makes sense.
Okay.
And so we'll rotate the crank over so that our rod pin is super far away from us. And I kind of give this one last wipe down. And if you look here, this rod has a big chamfer on it on one side, and the bearing is actually offset just a little bit with a gap right here.
Okay.
Let's come to this side of the engine, and you can see that on this side of the crank we have what's called the fillet. It's raised a little bit, and on that side is where that chamfer and the offset bearing are going to go onto.
We'll meet up.
So yes, it's directional on that side, and the more obvious is the valve reliefs.
Yeah. Yeah.
Obviously they only go one way. So yeah, so basically I take the piston, put it in gently. Whenever you're ready to install the piston, you want to make sure that this ring compressor is super square and flush up against the block. If there's any gap, those rings can pop out in that gap while you're driving it.
Okay.
And you can imagine, not ideal.
Yeah.
So I usually get it lined up, and I use my left hand, or one of my hands, and kind of push it up against the block. I come look on this side and make sure that the rod itself isn't super crooked or sideways or going to hit anything. And then one smooth affirmative motion, you want to pop it.
Looks easy enough.
And you pop it straight into the block, and then from there you can just, with a little bit of pressure, it goes
Try
right
and guide it on.
And we'll take our rod bearing cap, and these are numbered with a little laser etch, and they're married. So the cap has the numbers, the rod itself has those numbers. You want to make sure those are the same and they're facing each other. And then we'll lightly seat this together. We should have a little bit of side-to-side play. Yeah, looks awesome. Pretty cool. So the next one, I'll line up this rod, journal on the crankshaft, grab my next piston, carefully feed it and line up the rings. And this block has a plateau hone finish on it, and so you'll notice that once you get the piston into the block, it literally, the piston just glides into position. You could do this by hand. And just push it right to spot.
That's satisfying. That's really satisfying.
Super cool. Think you got it?
I think I can do that, yeah.
All right.
I think so.
I'm going to go ahead and put the piston in the ring compressor for you.
Yeah, I would
Get that
agree.
set up, and then
I'm on board with that.
so that's the right orientation.
Okay.
We've got the radius side facing the rear of the engine.
Okay.
And so just go ahead and gently pop her into place. that up flush, and then just give it a nice. Did it go all the way in?
I don't know.
One more. Perfect.
You gotta be pretty firm with it, huh?
Yeah, you really want to. I mean, it's an action.
I always feel like whenever I'm messing with nice stuff, I never want to hit it hard. So if I'm going to break it, but then you got to remember, you're not breaking these.
Yeah.
And if you do, that's impressive.
Yeah. If you can break a piston on install, you have done something terribly wrong.
It's like an Anchorman moment. Like
Yeah.
you're not even mad, you're just impressed.
Yeah. And again, if you look at the application and the life that these parts are going to have, I mean, they're designed for tens of thousands of G-forces.
Crazy.
At 8,000 RPM. If you do the math on like the weight of an average
Yeah.
aluminum piston,
Yeah, the energy behind that is
it's outrageous.
stupid, yeah.
And it might not be so much as a like popping it, more than just a pushing motion, just driving it
Yeah,
into
I gotcha.
place.
Good?
Yep. Perfect.
And they slide in so nice.
Yep. Yeah, after we put the shore block
That's
together,
so satisfying.
I want to show you our cylinder hone,
Yeah, absolutely.
how we make that happen. A good way of thinking about it is every single step is the most important step.
Yeah,
when putting
yeah,
the motor together.
yeah, for sure.
Because everything needs to be checked, verified.
It's crazy that it's all so precise that even though they look exactly the same,
Yeah.
like they need to go together.
Yep. Cool. So one bank is done. That is so cool to see those domes.
No, the satisfaction is nice.
So let's roll her over and do the same thing on the other side.
If you know all the little tips and tricks, there's not that many steps to it.
There really isn't. Now, of course,
You've done a lot of them already, but
there's a lot of stuff that went on behind the scenes, but yes, the actual physical assembly process is nothing more than a Lego set at this point. Just follow the instructions, it'll go together. So there it is, man. So all we got to do now is torque the rod bolts down, and this short block is done.
easy peasy.
So we're going to take this rod stretch gauge, pop it onto the bolt, and we're just going to zero it out to this fastener, untorqued. Let's check it a couple times. That's good. And let's go to 80 foot-pounds as our starting point. And if that's our correct torque value, this bolt should have stretched 5 thousandths. And so you can see right now we're about 6 thou,
Okay.
so a little bit high. So I'm going to go ahead and loosen it. Back down to 0. Let's make sure that we're zeroed.
I didn't even know this existed.
Yeah, we're still right on 0. And now let's go 75. You can see we are right at 5 thou now.
On the dot.
So we'll check that on one more bolt, but for now, this rod is perfectly stretched, or that bolt is at least. So we'll just make a little bit of a mark on it. Now let's do this bolt right here, just to double check ourselves. Make sure it wasn't a fluke. Get it on there, zero out our gauge. Carefully pop this back into place. And we're just under 5, but we're within 2/10. So you know what, that's good with me. maybe click this up a couple numbers. So it looks like we want to be somewhere right around 75 to 80 pounds. Yeah. So we're literally splitting hairs at this point. Cool. So now we know what to torque these to, and we can go through them knowing that we're doing it correctly and that the rod will have the correct amount of stretch, and so everything is lined up.
That's crazy.
Pretty smooth, right?
Very smooth.
Isn't that crazy?
Dude, it looks so cool too. It's huge.
Pretty neat, man. Okay, Jake, you've now built your first engine, and your first engine happens to be most people's dream motors. You have a 13.5 to 1 comp 416 nitrous drift engine with arguably some of the coolest pistons available out there.
Yeah, I would totally agree with that assessment. It's honestly a lot simpler than I thought it was. There's a lot more that goes on behind the scenes, and I'm sure you guys, I mean, you post so much of that stuff too, but man, that was cool to do. I appreciate it.
If they all find out, we might be out of work. It is pretty easy, guys. As long as you're super clean and you're paying attention to what you're doing and you do all the right prep work, it goes together surprisingly and shockingly simple when you think about and kind of take a step back and realize what application this engine's going into. It's pretty cool. Big thanks to Shay for prepping everything for us. All the bearing clearances were done, all the ring gap was done. I had the block already machined. And actually, I want to show you our cylinder home really quick while you're here, and what gives that engine such a smooth, perfect finish. So this is kind of the latest and greatest as far as honing goes. This is the Rottler H85. And I haven't shown too much of it, but what's really cool about this machine, well, it's cool for a lot of reasons. One is that it has 6 stone holders all the way around it. Usually machines have 4, like this hone head. You can see it only has the 4 of them.
Yeah.
And what the 6 does is it gives a more even distribution of load, because these stones are pushing out on the block, obviously cutting material. And so by giving it a more distributed load across the cylinder, you get a more round cylinder. And then as well, it'll automatically move itself hole to hole, completely automated, and totally machine your block in full.
That's crazy.
Yours has a plateau finish, which basically means we start with this stone and we take the cylinders all the way to the exact size. So your engine block is 4.075 bore diameter. And so these diamonds take it to 4.075, and they're a little bit of a rough finish. If you can feel that, it feels kind of coarse. Yeah. It's actually the equivalent of 200 grit sandpaper. So surprisingly coarse for,
that's not very...
for a piston ring. But then once it's at size, we take these are called plateau brushes, and they're the equivalent of about 600 grit. And we basically just do 5 super light strokes on the block with those stones. And that gives it this amazingly smooth finish that your block has.
Yeah, it just kind of cleans up that initial pass.
Yeah.
Makes sense.
And so yeah, so the coarser stones, if you can imagine, they're a little bit coarser, they've got big teeth on them, and they're carving, and they're just scooping out the material, and they're leaving an impression of themselves onto the bore. And so we use a thicker, coarser stone in the beginning because we want to cut into the block and leave a nice valley. That valley is a little bit deeper so it can retain oil a little bit better. But then we come back with the smooth stones and we just cut the plateaus off of those mountains that we made. So now we have something going on like this, and we have a super smooth finish with a deep valley. So the hone can retain oil to lubricate the rings, but is at the same time super slick to not beat up the ring.
That's fancy stuff, man. That's
Yeah.
cool. That's really cool.
There's a lot of science just behind honing, and yeah, it's a whole rabbit hole.
That's what I've kind of started to notice just today. It's like the assembly is simple, but there's so many little tips and tricks that you'd never know exist.
Yep.
Yeah, like there's so many things that you were talking about, and I was like, I didn't even know that was a thing people did. Never heard of it before.
Yeah.
And it all matters.
Pretty cool stuff. So I want to give a big thanks to Jake for coming down and doing this with us. This is a first for me as well, filming with somebody and showing somebody how to build their own engine. So kind of a trial run. I think it went really smooth and simple. It was pretty fun. Make sure you guys check him out on Instagram and YouTube. I'll put his link in the description below. Thank you for watching. Thank you to Jake, and we'll see y'all next time.